In this section, we're going to look at graphs of lines. Generally, lines are pretty easy to understand in the sense that from geometry we know that 2 points determine a line. So all I have to do is calculate 2 points, put them on the graph, slap the ruler down, draw a line. But there's some interesting things we can look at to determine from the line, or from the pictured line we can determine about the function. So the first thing is we're going to hold the intercept constant at 0, and then we're just going to manipulate the slopes to see what happens. So if I take the line y equals x, that purple one there, you can see that all the lines that are between y equals x, which has a slope of 1, and the vertical y-axis, all those have positive slopes bigger than 1. So that means that as the slope gets bigger and bigger, the line slowly becomes more and more vertical, or closer to being vertical. Now if I look at these lines between y equals x and y equals 0, I can see that all their slopes are less than 1 but bigger than 0. So that means that as the slopes get smaller and smaller, they're becoming closer and closer to a horizontal line. These slopes of lines in this area, they have slopes that are between -1, which is the slope of the light blue one, and as that negative number gets smaller and smaller, it's again becoming vertical. Now if I go to this last region, these are numbers between -1 and 0, so as the slope gets closer and closer to 0, then I know that my line is becoming closer and closer to being horizontal. If I look at now, hold the slope constant and change the intercept, I can see that where the yellow dot is, that the slope is 0 there. So it goes right through the origin, that's 0, 0. It's the only spot that has both y and x intercepts at the same point. But now if I look at everything above that, that would be where the intercepts are positive. I'm adding 4 and 2 in this example and pushing them up. And if I look at anything below the x-axis, my intercepts are negative, so we're going down. We're pushing it down, just like we do with transformation of functions. All right. If the graph of two linear functions are parallel, describe the relationship between the slopes and the y-intercepts. So notice that if I have two lines, y equals m1x plus b1, and line 2, y equals m2x plus b2, what makes them, if I know they're parallel, what makes them the same is that the slopes are the same. But it also means that the intercepts are different, because if they're not different, if the slopes are the same and the intercepts are the same, then it's just the same line. So I don't know if we'd really call that parallel. To be parallel, we're really thinking slopes the same and the intercepts are different, so it's two different lines. If the graph of two linear functions are perpendicular, describe the relationship between the slopes and the y-intercepts. All right, so in this one, suppose that the two lines, same thing, right, as above, but this time if L1 and L2 are perpendicular, then we know that the slopes are negative reciprocals of one another. Intercepts doesn't really matter, because obviously now they're turned a different directions, so they could have the same intercept, they could be different. That doesn't really come into play here. But there's one little exception, and that's if the linear function is a horizontal line, its perpendicular is vertical, which technically is not a function, right? So as long as you know where point and x point on the graph is, you know that all the verticals will have the same x. Just like a constant, all the y's will be the same. But 8. Going backwards here. 3y plus 4x equals 12, minus 6y is equal to 8x plus 1. All right, so this one, all right, so I'm going to solve both of them for y. So this one I'm going to subtract the x over, get 3y is equal to negative 4x plus 12. Divide everything by 3, negative 4/3 x plus 12 divided by 3 is 4. So this one has a slope of -4/3. Now this one I just have to divide everything by 6. So 8 over by -6 plus 1 divided by -6. So this gives me y is equal to, simplify this fraction, -4/3 x minus 1/6. Now this time, this slope has -4/3. Now this time, because they're equal to each other, right? My M1 is equal to M2, then I know that the lines are parallel. So are these parallel, perpendicular? So how do I know? So I just got to find the slope. Well, the slope of this one is 2/3, right? So I want it down here and see what I get. So what I'm going to do is I'm going to take this one, I'm going to solve for y, just so it's just like this one. So I subtract that over. I get 2y is equal to -3x plus 1. Now I divide everything by 2. Notice that the slope for this one is -3/2. So if I took the first one and go -1 over 2/3, I'd get -3/2. So since those are the same, then I know that these lines are perpendicular. Let's do 14 and 16. H of x is equal to 3x minus 5, and 16 is -2x plus 5y equals 20. It says find the x and the y intercepts. All right, so right, x-intercept means that y equals 0, and y-intercept means that x equals 0. All right, so for the first one, for the x-intercept, we remember the y is the function. This is just another, that's just another name for y. So really, just put a 0 in here and then solve it, right? So you can either just look at it and say, oh, it has to be 5/3, or you can figure it out by adding the 5 over and then dividing by 3, right? So the x-intercept is, now intercepts are actually on the graph, so this would be 5/3 and 0, like that. Now x equals 0, y-intercept is just plug in x equals 0, so all you have to do is just, put your finger over it. Well, that's the b, so really you don't have to do much of anything, just write it down, right? The y-intercept is the y-intercept when you throw the 0 on, like that. That's it. Just read it. Now this one, right? I like finding y-intercepts because this is use your finger, right? 0 for the, so we have 0 like this. So the y-intercept is make x 0. So what do you do when you make x 0, right? That's -2 times 0 is 0, so it's gone. So I just have to put my finger over it and ask myself, what do I multiply 5 by to get 20? Well, that's 4. Now, when y is 0, 5y would be 0, so I just have to put my finger over it and go, what do I have to multiply -2 by to get 20? And you go, -10. Like that. Oh, let's see. I don't know. How about 20? We'll do 20 here. Line 1, so L1, passes through 2, 3, and 4, -1. Line 2 passes through 6, 3, and 8, 5. And that's nice. What are our directions? For the following exercises, use the descriptions of each pair of lines given below. Find the slopes of line 1 and line 2. Is each pair of the lines parallel, perpendicular, or neither? All right, so the first thing we want to do is look at the slopes. Because if the slopes equal each other, they're parallel. If they're negative reciprocals, then they're perpendicular. And if they don't match up at all, then it's neither. Then there's one other step. If it's parallel, we have to check to see what the b's are, because if the b's are the same, that's just the same line. And so technically it'd be neither then too. So let's find the slope for each one of them. So this one would be difference in the y's So that'd be -1 minus minus 3 over 4 minus 2, which is -4 over 2 is -2. So this slope for this line would be difference in the y's, 5 minus 3 over 8 minus 6. So this would be 2 over 2, which is 1. So neither would be our answer. It's not parallel, it's not perpendicular. All right, let's try 26. It looks different. Write an equation for a line perpendicular to h of t equals -2t plus 4 and passes through -4, -1. Okay, so we want to come up with a line perpendicular to this. So with these equations, we tend to use, we could use this, we could use this form to find the equation, right? Or you could use this one if you really want. Either one of these will find the equation. So all we need for both of them is a slope and a point. Here, you would plug the slope in here, and then your point in for x and y and solve for b, and then just plug it all in. Here, you plug in the slope, and you plug in your x and your y, and then solve for y over here by adding it over, and you should get the same thing. So just let me do it. I'll do it twice, once each way, just to show you, and then you can pick whichever way you like doing it the best, because that's the way I think you should do math, is find a way that you like and stick with it, but don't forget the other way, because occasionally it works better. So, all right, so perpendicular to gives me a hint about what the slope has to be. So perpendicular to this, so my slope has to be negative reciprocal, which would be a positive 1/2. And they give us a point. So here's our x1 and our xy1, like that. So when I plug this one in, I'm going to put in y minus -1, 1/2 x minus -4, right? Minus negative. And so then I can take y is equal to 1/2 x plus 4 minus 1, like that. Distribute the 1/2. Combine the two. And there we go. There's the equation of the line. That's, so I guess we could put it in a function notation for, if we want, just to keep consistent with the way they gave us the information. Now I could do it the same way here, since once I have the slope, this I still have to do the same way. Now I could plug in the y here, the 1/2 there, the -4 there, like that. 1/2, that's -2 plus b. Now add that over to the other side, right? 1 equals b. Now I can just plug in my m and my b, and I get y is equal to 1/2, that's my m, plus my b is 1. And so I get, notice I get the same exact thing. How about 24? So we want to find a line parallel to f of x equals minus 5x plus 3 and passes through to -12, like that. All right, so again, all this is telling us something about the slope of our answer, right? So parallel lines have the same slope. So my solution should have a slope of -5, because this has a -5, so this one's gonna have negative. Now it passes through that point. So now I just have to plug it in. -12 is equal to -5 times 2 plus b, right? I'm going to use the y equals mx plus b way. So this is -12 is equal to -10 plus b. Add that over, so I get -2 is equal to b, right? Add 10 to both sides. And then I'll just plug it in. Y is equal to -5x minus 2, like that. Let's try 27. 29. Find the point at which f of x intersects g of x. All right, so you want to find the spot where, find the intersection. So just as a quick graph, just to show you how you can do this, just to get a mental picture of what's happening here. Positive 5 with a positive slope looks something like that. Negative 5 with a negative slope looks something like that. So we know these two lines have, based on the picture, I can tell that my y is going to be negative. Now my x, I'm not sure because I drew it so bad, but how do you find this spot? Well, this spot right here, whatever that x and y is, that's the same in both of them, right? If I plug in whatever this number is here and here, I get out the same thing. So that means that these two have to be equal to each other. So once I do that, right, we have the transitive property. If A equals B and B equals C, then A equals C. Transitive, right? So if A equals B and B equals C, then A equals C. So I do a 2x plus 5 is equal to negative 3x minus 5. So I'm going to add this one over here. So that gives me add 3x, so I get 5x. Subtract the 5 off of this side, so that gives me a negative 10. Divide by 5, so that gives me a negative 2. So x is negative 2. Y, now, since these y's are the same, it shouldn't matter which one I plug it into. So if, say, I plug it in the first one, f of negative 2, that would be 2 times negative 2 plus 5. That's negative 4 plus 5, which is 1. And if let's just plug it in the other one just to show you that it is the same. Negative 3 times negative 2 minus 5. So this is 6 minus 5, which is 1. So we get our answer is negative 2, 1, like that.